So welcome everyone. Thanks Joao for inviting me to this workshop. My name is Mario Garzón. I work as in Technical University of Delft, as you say. And today I will be talking about simulating drones with Gazebo. I will be doing a very brief presentation of what can be done and what are the packages that are mainly done. It's not a tutorial or nothing. There is lots of tutorials and information on the internet. So this is more like getting to know what is there and what is being used for. About me, so I've been working with drones for around 11 years. I mostly work with the heterogeneous multi-robot systems, either with drones or ground robots for tasks that include coordination, cooperation, and decision-making with those robots. And a bit of publicity, of course. I'm the coordinator of the MOOC Hello Roll with ROS, which is an online MOOC that we offer at TUDelft. And it's a very useful tool for someone that wants to start in the world of ROS. So if you want, you can check it. We're actually preparing now the next version for the next year. So this is the presentation outline. I will start with a brief introduction, and then I will discuss some of the previous packages, because I think that it's important to know the packages that maybe are not so useful now, but have been used before, and many researchers are still using them. Then I will talk about the PX4 autopilot, which is the one that is currently, I think, leading the uses. I will try to speak about something on the Gazebo limitations, and finally I will give some alternatives to Gazebo for people that maybe want to explore a different simulator. So, of course, there is no doubt that the simulations are incredibly useful. We need to do simulations in order to improve the speed in which we do development. That will also allow us to have an unlimited range of sensors, plugins, models, and for free or for very cheap. So this is really, really useful. Of course, it's safe for equipment and users. I think everyone working with drones drones in the real world has crashed a drone sometime in his life. So simulation can help you avoiding those things. And finally, one of the main points about simulating drones is the ability to share or reproduce either your results or your data or your algorithms. This is a very important point, because one of the main issues that we have maybe in the robotics community is the reproducibility of the results and the experiments we do. And although, of course, simulation is not the perfect tool in every way, it's one very interesting way to actually help other researchers have the same results as we do. There is, of course, an issue with the drone simulation, and is that I think that you can have either real-time, or in some cases, for instance, you need faster than real-time simulations. In some other cases, you want some realistic rendering, some photorealistic rendering. In some other cases, you will need some very accurate physics and dynamics. If, for instance, you're developing some drones, then maybe you need some very accurate aerodynamics. And in some other cases, you need lots of sensors and lots of payloads, cameras, laser, and many other things on board the robot. You can have many other stuff, of course, but it's very, very hard, not to say impossible, to have everything in one single simulation. So my point here is that simulations are very useful, but you need to know what you want to do with them, and what is your target, and what needs do you have. And having that defined, then you can, of course, select the best simulator for you. Why Gazebo? So why I'm recommending Gazebo? It's because Gazebo is a very common, widely used in the ROS community. It's defined as a very accurate and efficient simulation for populations of robots. I put an asterisk on those two affirmations because yes, it's accurate and yes, it's efficient, but you have to make sure that what you're doing is what you want. It's not depending on what you want to do, especially if we're modeling drones, aerial drones, may not be as accurate as you want to, but I think it's still a very useful simulation. One very interesting thing is that you can create complex indoor and outdoor environments. And Gazebo is well known for this. There are many environments that are created in Gazebo. There are many environments that are available for you in Gazebo. So this is something that you can take advantage of. Of course, another main advantage, a big one, is the large amount of robots, sensors, and plugins that you can find in ready for Gazebo. Almost all commercial robots used in research are available in Gazebo with very well-detailed models. You can have all types of sensors. You can have plugins for control. You can have plugins for many applications. And this is something very useful. So this can help you a lot if you want to speed up your results. Of course, it's it's open source, and it has a very large community of users. Usually you can have lots of help and lots of responses, lots of tutorials and information online. So it's very easy to find the information you're using. I think it's the most used simulator in the ROS community without a doubt. What are the main features of Gazebo? So basically, Gazebo uses a dynamic simulation. I'm sorry. It mainly uses the OpenDynamic engine physics engine, but you can also use some other physics engines. It uses Ogre for getting graphics, and you can have, of course, sensors with noise. You can have lots of plugins, as I mentioned before. There are command line tools. There are cloud simulation tools. So really, Gazebo has a lot of features that you can take advantage of. This is the architecture that Gazebo uses. So basically, Gazebo is divided in two main parts, the server and the client. The server can run in any machine and does not require a graphical interface. So you can run it in a server or in the cloud. And this is where the physics and the plugins and everything, the control is done. And it's also where the sensor data is generated. And this information you can connect to or get via client. The client can be the Gazebo GUI, which is the most commonly used, but you can also access the information with the command, the control, the console command, or by your own software. So I will talk about a bit the history of the packages that have been used historically for drone simulation now. The first and the main one is the Hector Quadrotor Gazebo, which was developed by TUDelft. And this is part of a meta package, a group of packages called the Hector packages, which were developed for urban search and rescue, specifically for the RoboCube competition. They included several useful plugins like IMU localizations. And unfortunately, this package is no longer working. I think the last working version was for ROS Kinetic in 2017. But some of these components, especially Hector Slam, which was one of the most successful ones, are still available. This is a small video of what you can do with the Hector Gazebo. This video is from the Technical University of Darmstadt. As you can see, Hector did not simulate the propellers or any aerodynamics. So it's basically a floating base there, but you can already add sensors and have some control. This package, you could actually directly send speed commands. So it was very easy to control. And of course, since it was not really an accurate flight simulation, it was you didn't have much problems of the robot falling or crashing or something like that. So it was really useful. And I think it was a very useful tool for people who started working with drones in Gazebo. And it was widely used until I think 2015 or 2016, in which were more advanced simulators came to work. The next one will be the RDrone simulation. Of course, I think we all know the Parrot RDrone. It was a very popular, cheap drone. And there was an interface called the RDrone Autonomy. And then in the University of Munich, they developed a simulator for this package. It was basically the same plugins as the Hector one. This had the ability of the thing, since the package, the RDrone had 2 cameras in real life. You can start doing some computer vision algorithms with it. It was also maybe one of the first times where the robots have the same interface for a real robot and a simulation. And this was something that make it very, very successful, because you can test already with the simulator and then go to the real Parrot. This is a very quick video of it, also from the University of Munich. And here you can see that you can have the quadrotor and the real robot in similar scenarios and doing similar behaviors. Of course, it's not exactly the same, but you can control both quadrotors, real and simulated, with the same interface. Finally, the rotors simulator.
Online workshop.
I'm sorry, I think someone has a mic open. If you can maybe mute it.
Internet
so I continue. There is the Rotos simulator developed by ATSZ. And this was a simulator that developed models for the Aztec quadrotors. It was also very, very popular, and it included also a visual and inertial sensor. And as with the RDrone simulator, it has a specific target with the real robot, which make it very useful. Also, this was the first widely used simulator that actually used aerodynamics as a plugin. So in this case, they were developing a tool that actually simulated the propellers and the liftoff generated by them. The last official version was in Roskinetic until about 2018, so not so long ago. But I've tested it, and it still works with the Melodic and Gazebo. So if you want to use it, it's still possible to use it. Now we go to the current status, where there was a sort of change of paradigm. The idea was not to model specific robots, but rather to change to model the autopilots. And this was, of course, with the advent of MATLink and the widely use of MATLink. Then the idea was how to start using the autopilots in Gazebo. And for this, of course, they developed drones that use the LiftDrag plugin, which also includes full aerodynamic modeling. And there are specifically 2 main options, the ArduPilot and the PX4 pilot. Both of them are very similar in terms of their software simulation. And of course, they are mainly focused for generic drone, like the Iris that is available in Gazebo. So if you are using either the ArduPilot or the PX4, then it should be not so complex to put them on Gazebo. And if you have one of those in your drones, then you can just easily select which one. I will talk about the PX4 mainly because it's the one that is officially supported by more, let's say, continuous development, whereas the ArduPilot is mainly more, let's say, individuals doing the development. As I mentioned, the PX4 is developed by Drone Code, which are the maintainers and creators of MATLib and QGround Control. So they have a very strong team behind them, and it's strong as a team that is doing a lot of development and taking this to very recent and interesting simulations. It provides two types of simulation. The first one is software in the loop, where you just don't need anything. You can just have the autopilot simulated in Gazebo. And the second one may be something interesting for people already using, which is the hardware in the loop, where you can actually plug the autopilot to your port and do the control through it. So this will be closer to what you actually will have in the real robot, and of course will help you speed up your development. This is a small video of a simulation using PX4. Here you can check that the robot is in a scenario where you can have laser, you can have camera, and you can have a complex scenario. And as I mentioned before, this one is actually getting some information from the drag. So what's the advantage of using PX4 on Gazebo is that you can have all the Gazebo goodies. You can have lots of sensors, camera, IMU, laser, everything you can put on your robot for free, and you can put it even without changing the weight if you don't want to. So you can actually have a lot of interesting tools and features for you. Since it's already on Gazebo, it's very easy to integrate with other robots. So if you want to do multi-robot systems, or you can want to cooperate with ground robots or other types of robots, it's a very interesting tool for do that. Of course, the connectivity with the ROS environment is complete, so it's very useful in that sense. And as I mentioned before, the translation to real robots is very easy because you can actually simulate the autopilot, so it should be more or less the same commands. And the PX4 has a really great community of users. There are many tutorials online. I was not planning on doing tutorial because you can really find a lot of information, a lot of videos, people doing all the configuration online, and lots of people that can help you with the answers of questions if you have some. What are the typical applications? As I mentioned before, the main application may be high-level task programming. So if you are doing programs or you're using your drone to develop some robotic applications, then I think working with Gazebo and the PX4 is the best way to do it. You can have sensor fusion, you can have localization algorithms, you can have other robots to coordinate with. And as I mentioned before, you can explore complex scenarios. So there are houses, there are caves, there are fields. All of Gazebo's words modeling tools that are already there. You can have models of people. You can have all sort of already available models that you can take advantage of when you're working with Gazebo. The downside of Gazebo and PX4 is not so easy to have it running. So if you are new to ROS or you are not so very skillful with Ubuntu, I mean, there are lots of tools and scripts and you have to follow them, but you may have some hiccups on the way. But as I mentioned before, there is a big community. There is a lot of tutorials. There is a lot of people with videos on how to do it step by step. So I'm sure you will have it running, but you should be aware that it is not like click and install and it works. You have to take some time to make it work. Of course, it's not the tool for learning to pilot, how to pilot, because the physics and the simulation is not so accurate. So if you want to train a pilot with this simulation, I don't think it's the best tool. And the image rendering in Gazebo is not so great so far. They are improving it a lot, but is nowhere compared what you can find with more photorealistic engines. Some alternatives to Gazebo, just to finish my presentation. So also there are this simulator called Flightmare, which combines Gazebo with Unreal Engine. It's a very interesting simulator because you can have all the advantages of using Gazebo, but you will have a photorealistic environment provided by Unreal Engine. And at least according to the developers of the simulator, you can have up to hundreds of quadrotors. So if you want to simulate a swarm of quadrotors, maybe this may be a tool. The disadvantage of this was maybe that is still a development is in the phase of development. I think it's been released just last year. So there may be some things that still don't work quite well, but I think it's a very interesting tool. Another option is AirSim, which is mainly focused for machine learning. So if you want to do some machine learning, that's mainly a good tool. It also uses Unreal Engine. The main disadvantage of this is that is not native to ROS, but it uses a wrapper, and you can put it to work with ROS. Finally, some simulators that are more closely similar to Gazebo. I will mention Webos, of course. Webos was previously a closed simulator, but it became free actually from in 2018. And it has seen a big increase on users. You can have a lot of robot models, mainly ground robots, not so many UAVs, but there is the DJI Mavic 2 Pro. So it's already available there, and it has also very good rendering and a good physics engine. Also, the Coppelia Sim, or previously known as BREP simulator, which has I think has a much better physics engine. So if you are interested in model physical iterations, that will be the tool I will recommend for. So that's it. With this, I finish my presentation. Of course, let me know if you have some questions or comments on it.